Thank you for
Yes.
doing that, Lisa.
Mute
Okay,
yourself.
so I do know and I recognize several of you out there. It's wonderful to see friends. As you know, we're kind of starved for seeing friends nowadays, right? For actually having some contact with other people. But I will give a short introduction for those of you whom I don't know already. My name's Connie Mutel. And if I would think about what I've done in my life, I think a lot of it has been centered around plants. I think I was born with a love of plants. I think I got it from my family. My grandfather was, I like to tell the story about him being a Lutheran minister in a small town in Wisconsin about 100 years ago. And his claim to fame was his garden. I assume his sermons. I don't know about that, but I do know that he was supposed to have a wonderful garden, and that on Sundays after he gave sermons, he would go out into the field. He'd come home, take off his clerical garb, put on his mucking boots, and take his plant guide and go out into the field and spend the rest of the day out having fun in the woods in Wisconsin. And I kind of envy him for doing that. I think that there were probably a lot more native places with native plants then than now. So, and my father was a forester. I'm a plant ecologist and a botanist by training, and our son is, one of our sons is what's called, and he calls himself, an environmental psychologist. So you can guess what that is. I think it basically combines his love for nature with his research on what contact with the natural world does for the human condition and for health problems in particular. So we've got a long family line of plant lovers, nature lovers, and that has been the basis of my career. I just recently retired from the University of Iowa, where I did environmental writing for the last 45 years, I think, something like that. I'm a practicing Christian, and a lot of my faith focuses on my sense of the Creator and the creation. As we all know, God is that branch of God, or whatever you want to call it, is one part of the Trinity, but I think it's often ignored. But that has been the focus of my life. So I really have a passion for the natural world and have dedicated my whole life, quite naturally, both professionally and personally, to actions that try to defend the natural world. And so that's who I am. I have ended up doing a lot of writing, written several books on the natural environment. The latest one was published 4 years ago now, A Sugar Creek Chronicle, Observing Climate Change from an Iowa Woodland. I think that's correct. And it covers both descriptions of the woods where I live and climate change. And I came to the thought of writing this book later in my life when I realized what a huge problem climate change is. And I said, before I retire, I've got to do something about it. And that book was the result of that. And since that book has been published the last 4 years, a lot of my writing and speaking to public groups has focused on climate change because it's such a huge problem. So, climate change, I have obsessed about it. It's kept me awake at night for years now. And then all of a sudden, this pandemic strikes at the beginning of the year. And by March, and overnight, literally overnight, all of us had our lives changed in a matter of hours. In a matter of hours, we couldn't do the most familiar and enjoyable things, little things that I never appreciated, like strolling down a grocery aisle and lingering over what items I would purchase. I don't do that anymore. Seeing friends freely, calling up somebody and saying, let's have a dinner together. We just don't do that anymore. It's changed our world tremendously. And since then, we have had an onslaught, I think, of crises. First the economic crisis and all the millions of people, how painful it is with all the millions of people losing their jobs and their livelihood. And then all of the associated things. One of our children is really concerned because he's got to start teaching in a couple months, and he doesn't know, his wife does the same thing, and they don't know if they're going to have childcare, if the childcare center is going to be open. You know, this is the major thing in their life right now. And it wasn't, a year ago, they couldn't have even imagined, could not have imagined how much their lives have been changed. And I think it's a really hard, tough time for us to be alive. I keep saying that. It's a hard time to live in this world. And then on top of the economic stuff, all of the pain of the, you know, the Floyd murder, and realizing, coming to closer contact with the number of people whose lives they feel are daily threatened. We have two grandsons who are Black, who identify themselves as Black, and you know, they just speak about their fear of going outside and having contact with white people. It's horrible. It's a horrible time. And then the police brutality on top of that. So we have all of these things that we're struggling with. And this talk had its genesis right at the eve of our first COVID shutdown. So I was supposed to give a talk in April at Wartburg Theological Cemetery. Oh, that's horrible. Seminary. And instead of being canceled the way most events were, the organizer of the conference said, well, we're going to do it. We're going to try to give a Zoom conference, which they did. And they did it beautifully. And the main speakers, myself included, managed to give Zoom presentations. We all since have written journal articles on our presentations. And it was a big success. But when I was going into planning for this talk, I thought, I can't go in and talk about climate change. You know, people, if you remember back in March and April, which seems like a lifetime ago to me, my husband and I were really talking about what happens if we die, right? We redid our wills. I bet a lot of you out there redid your wills. And, you know, just started to make plans for our future, however long that would be. And I thought, I can't just come in and say, hey, we've got this horrible pandemic and economic problems, and now let's talk about a problem that's even bigger than that, climate change. Just didn't feel right. So what I thought is, instead, I said, I'm going to compare the two and see how they're similar, see how they're different, and see what COVID, which we were all obsessing about then, or at least I was, what COVID teaches us about climate change. So that was the genesis of that talk. That talk went, I believe, well. People seemed to receive it well. And so now I'm giving it to the Our Lady of a Prairie Retreat group. I am on the board of Our Lady of the Prairie, and I love the place, and I love the people that I've gotten to know through being involved there. So that's kind of who I am, a little bit about me. I'm also a mother. I have 3 grown sons. We have grandkids that we adore. My husband is just retiring. He didn't have his retirement party this year because of the COVID. We can't take the trips that we were hoping to take after retirement. We can't even plan them. You know, a lot of changes, but on the whole, we have been extremely blessed because we have a home where we can feel safe, as do all of you. And I think that's as important as anything that we can hope or pray for. So a little bit about me. What I'd like to do today is do this comparison of COVID and climate change. I think that probably some of you know a fair amount of, I know the 2 Beckys there know a fair amount about climate change. So you might get a short review. I hope it won't be too long for you. And then put together some things that I've learned about COVID and compare them. And it'll be partly a way of transmitting information, I think, but also partly a way of just helping us put all of this stuff that's going on in our lives, hopefully, into some perspective. and to allow us to talk about these things, to allow us to talk about where we are now, where we hope to go, what our future might contain. I know some of you are activists. I know the several sisters that are there. Doesn't matter, you guys don't retire. I know that, like I have. You keep active until you simply can't get out of bed to do it anymore. And I love that in the sisters that I know. And so you're all, many of you are activists and struggling to ensure that the world that we have today remains habitable, remains beautiful, remains open to people for the indefinite future. So I hope we can think a little bit together, explore together, talk together. This is scheduled for two hours. I don't think we'll necessarily take all that time. I don't claim to know the answers to all of the things that I'll be talking about or the questions that you know. This is very much a work in progress. So let's get going. I'm going to go to share the screen. Let's get going. And if you do, I said that I only wanted to answer questions at the very end, but if you have something you just want to say, just raise your hand, pretend you're back in grade school, and Lisa Martin there, who is a good helper, will kind of let you in and you can interrupt me, and that'll be fine too. So here's my very pretty introduction slide, dress rehearsal for the climate change crisis, ? And my answer is going to be yes, it is. So in this talk, I want to compare the COVID-19 pandemic, which in the talk will be CV with climate change, CC, and you'll see my two symbols there for the virus and for climate change. And what I'll talk about are what warnings have each of these given to us? What scientific proof do we have for each of them? What are their effects? What are their endpoints? And what solutions might we have for each of these problems? And then address the question, can the COVID pandemic help us deal with climate change, help us give us some new ways of thinking and acting with climate change? And what I've come to with my work and a lot of thinking on this subject is, yes, very much it can. So here we go. And let me apologize in advance for my throat. I don't have COVID. I have a throat that I think has been overworked, and sometimes it gives out, but we'll hope for the best. So what warnings did we receive about their arrival? And there we go. And their impact. And what I want to say is we have had plenty of warnings for both of these things. We've had two coronaviruses preceding this, the MERS virus and the SARS virus, both of which were transmitted from animals, both of which are coronaviruses, both of which were expected to become world pandemics. But those two were not quite as infectious as the COVID virus. And so we didn't, we didn't have, thank God, we didn't have the pandemics in earlier years, but this coronavirus has been much more infectious and it spreads more easily. So what warnings did we have? Oh, here, just a sec. So both the COVID virus and climate change gave plenty of warnings over decades, you could say. But have we responded well? I think that's the big question. I don't think we've responded as well as we could to either one. Let's look at the COVID virus. And it appeared first in November 2019 in Wuhan, China. By January 21st, it was confirmed in Washington State in the United States. By March 11th, it was a World Health Organization pandemic. That meant that it covered a large area and had many victims. By March 17th, it was found in all 50 states. By late March, it was in most countries in the world, and we were also concerned about the economic shutdowns that were happening. By mid-April, the US had the most cases and the most deaths in the world. So The dangers of COVID virus have been obvious since January. It was known from the beginning to have a rapid human-to-human spread. It didn't just go from animal to human. The humans then could transmit it to each other. It spread easily and rapidly, and it could cause severe illness and death. But in this country, in the US, it wasn't, and really actually around the world in many countries, it wasn't until early March that we had placed a priority on public health preparedness. And that is interesting. That delay was interesting and is important. There was a study down at Columbia University that was published in May of this year that stated that if we in this country, in the US, had adopted social distancing 1 month earlier than we did, on March 8th instead of March 15th, that 1 week difference in public health preparedness would have saved 36,000 lives in this country. So the delay in action was significant. And we can see that already by April, with lack of adequate response in many countries, we had the COVID virus really spread pretty much around the world. A few countries that didn't have it yet, but they had it soon thereafter. And we had that logarithmic increase in the number of cases and also confirmed deaths. July, yesterday, in the world, we had 11.3 million cases. We had about 60 or 70,000 in April. We now have 11.3 million cases confirmed. That's a really steep growth curve. And we've had about 500,000 deaths around the world. So what about climate change warnings? So climate change started around 1750 with the Industrial Revolution, with the switch from animal and muscle power and water power to burning of fossil fuels. And in the 1800s, starting about 50 years later, we really had basic climate science established. The first step toward that was in 1824, when the French physicist Joseph Fourier described how the atmosphere keeps the Earth warm. He explained that if we didn't have the atmosphere with its carbon dioxide, the carbon dioxide molecules sending the heat back, the infrared radiation back to the Earth, bouncing it back time and time again, we would not have a habitable planet. The planet would be considerably colder and not habitable. But because of carbon dioxide, we have a temperature, we used to have, I think it was about 56 degrees Fahrenheit. Now it's 57, something like that, maybe 57.5 degrees Fahrenheit, average temperature in the globe. And the temperature, he said, as we burn more fossil fuels, the carbon dioxide concentration would get higher and the temperature would increase. So he basically defined this greenhouse gas and the greenhouse effect, and the climate change phenomenon, although he didn't call it that, he defined that 200 years ago. This is not a new science. By 1864, an Irish physicist, John Tyndall, had identified all of the significant gases. By the greenhouse gases, there's several of them. By the 1870s, we started to have systemic weather measurements being made both in the US and elsewhere around the world. And by the end of the 1800s, we had a Swedish scientist, Svante Arrhenius, saying that burning coal enhances the greenhouse effect. This man also wrote the first book for lay people on climate change, and he made the first climate change calculations. He calculated if we had a doubling of carbon dioxide, how much the temperature of the Earth would increase, and he got it pretty much right on the head without any modern computers at all. In the 1900s, the last century, we had climate science solidified. The big thing here was 1858, when an American geochemist, Charles Keeling, started measuring carbon dioxide in the atmosphere, he did this from an observatory that he established on top of a volcano in Hawaii. And he gave the first numbers for the fact that climate change was happening. He measured the annual increase in climate change. And within a couple years after his first measurements, he showed that each year was getting a little bit hotter, more carbon dioxide, and a little bit hot. That would cause it to become a little bit hotter. So this was the first proof that the increase in carbon dioxide was causing an increase in temperature. And by March of this year, we have a carbon dioxide concentration of 414 parts per million ppm in the atmosphere. I'll show a graph on this, but it hasn't been this high for hundreds of thousands, if not millions of years. So this is a significant increase. In the 1950s and 1960s, we had increased warnings. Scientists were saying things like, now we're carrying on a large climate experiment. In 1988, the IPCC was formed, the Intergovernmental Panel on Climate Change. This is the most esteemed group of climate scientists from around the world, not just the US, but international group. And this group of scientists in various other occupations, and they're around in universities and research labs around the world. They do very detailed scientific reports that come out every 4 or 5 or 6 years. And their reports are really the best tracking of what's happening with climate change. We also had in 1988, James Hansen down there he was a government scientist. He gave the first formal testimony on climate change to the US Congress. The US Congress was suitably, rightfully alarmed, and they tried to pass in 1989 a carbon tax, which was at that point, it would have been a very small impact on the economy. It would have been highly effective if they had passed that carbon tax. It might have changed the history of climate change, period. But unfortunately, that in response to that legislation, the fossil fuel companies got together, formed a lobby which killed that carbon tax and changed history in a bad way. By 1995, we had reports of polar ice breakups. People could see that the ice at the poles was crumbling and melting. And in this century, in the 2000s, we have had climate changes intensifying and warnings becoming more strident. 2009, climate change is happening at a more dangerous pace than expected. 2015, we had the Paris Climate Agreement. That was a good thing. 2016, President Trump was elected, and one of his first efforts was to pull the US out of that Paris Climate Agreement, a very bad thing. 2018 and 19, several major reports from the IPCC. And the one that people cling to the most is this statement, the report that said by 2030, we must reduce carbon emissions by 45% to avoid major tipping points. Excuse me, just a minute. To avoid major tipping points. Tipping points are points of no return. We'll talk more about them in a few minutes, but that's where we're at now. We're not at the point where we can prevent climate change, where we can bring the temperature increase back to normal. But we are still at the point where we can avoid huge changes, huge swings in the Earth's climate. And we need to get in and act to do that very rapidly. By this year, many nations around the world are taking action. I would say most nations are taking significant action on climate change, although the United States federal government is not, but the states and a lot of the cities are doing things. But the combined efforts still, it's very impressive, but it's not enough. It's just not happening fast enough. And the thing I like to think about is this. If you have a problem, you have a house burning down, and you don't address the problem rapidly, it really doesn't matter if you address it too late. If you call the firefighters early, they can stop the fire and your house can be saved. If the house burns down and you call the firefighters then, and they come and put out the ashes, that's good. It's good you've done something. But if you do it too late, it really doesn't make much of a difference. We've got to speed up our action. It's not an option, yes or no. This is something we need to do, speed it up, take bigger actions fast. So, summary about the warnings. Both climate change and the COVID pandemic have had adequate warnings early, but these warnings were often ignored or discounted. You know that both have been called a hoax, a political ploy. Other people have been blamed for causing them. And now the warnings for both COVID and climate change are to some extent heard and acted upon. We are acting on them. But valuable time has been lost, and thus the threats of both COVID and climate change have intensified, and they've both become more damaging and difficult to address. So the lesson we learned here is that we need to heed warnings and address problems proactively. It's hard for people to do. We want to wait till the problem has developed and then we get in there and save the day. That's not going to happen with either of these. And the longer we ignore the problems, the more difficult, expensive, and less successful our mitigation efforts will be, and the worse our future. And I think we're learning that now with the COVID pandemic, with, where states are having to go, as you well know, back into shutdown again. And it's really, really a tough time to think about going back into shutdown after we started to come out. Anyway, second question, science. What about the science of both the pandemic and climate change? Have we gathered enough valid information? And here, what we look at is how much data we have. When we talk about doing science, we're talking about gathering little bits of information that prove or disprove a hypothesis. And so we need data, often numbers, not always, but often numbers, not anecdotal reports. We can't say, well, my Aunt Matilda got better, so climate change or COVID pandemic isn't real and most people will get better. That just doesn't matter. We need broad spanning data and scientific research and reports. And what we can easily and rapidly see is that both the COVID pandemic and climate change have abundant supportive data. There's no question about the fact that either of these exist and are big problems. So with the COVID virus, we have numbers of diagnosed cases, of deaths, and the states and countries involved. So, and these data are expressed verbally. For example, on July 6th, in the US, we had almost 3 million cases total, and we had 130,000 deaths, and the numbers of both are growing at this point. We can express the data in graphs, look at the COVID virus and see that both the number of cases and total deaths have increased. These graphs are from April, but the current graphs would just follow up on that logarithmic increase. And we have maps. There again is the map of COVID distribution around the world back in April, and the map of US COVID in the US yesterday. And the darkest blue color are states that have had a total of 40,000 or more cases. And then it steps down a little bit more from there. Iowa is in the next ring, and I'm sorry, I don't remember the number of cases with that. And then the kind of light green and the lighter green and the whitish colors. So we can see there's that kind of partial halo around the southern and borders and ocean states, east and west states, where the numbers are the greatest. And we can also use the data to do computer simulations. These are mathematical formula that are put together, very complex computer simulations to figure future trends. And here's an example of one. This was done by a university in Britain, and it looked at the critical care beds available in Britain, and that's that bottom line down, bottom red line. And it looked at, for per 100,000 people population, and it looked at the number of cases of COVID that we would have under different scenarios. So for example, that first black line is the do nothing. If they didn't do anything in England, what you'd have is this big spike that goes rapidly up and rapidly down. And the problem there, as you recall, this was the time where we were talking about smoothing the curve. What the whole emphasis then was getting the number of cases to occur over a longer time period so that you didn't have such high peaks. And you could, for example, here with the orange thing, if you did case isolations, and then if you did isolations and household quarantines, and then the blue case isolations, home quarantines, and social distancing, you would smooth that curve. And that was what people were trying to achieve back in April when this research was done. So that's done all with predictive computer models by people sitting at computers all day long. So these models help plan for the future. They look at multiple scenarios and look at the effects of the effects of different scenarios. And these were all aimed at flattening the curve of illness. So for climate change, we also have lots of data. We're now measuring the globe's temperatures in thousands of places and times of day, every single day. Every single day we have thousands of temperatures taken. Dating these temperature measurements date back over a century. They're feeding thousands of research projects, and they allow us to calculate the global average temperatures. We're also measuring carbon dioxide concentrations in the atmosphere now, not just in Hawaii, but at several sites around the world. And the temperature, going back to the temperature measurements, we're doing these on the land surface. We're doing it from satellites, temperature measurements from satellites above the air. We're doing it by in the oceans, both. We're measuring temperatures on the surface of the water and deep down, as much as a mile down into the ocean. We have these little robotic measuring instruments there on the right. That yellow long thing will plunge down into the ocean, take temperatures about as deep as a mile in the ocean, and then come back to the surface and send the temperature measurements up to a satellite where it's recorded. And people are working with that research. And every single day we can calculate the increase in global temperatures. These little things like that thing going into the ocean are called Argo floats. Here is just a map to show you how many places we're taking measurements. If you see all those specks, those are specks on the oceans, and each speck is for an Argo float, which is in operation in that location in the ocean. And this is being done by countries around the world. So very, very sophisticated and accurate measuring of temperature right now going on. Temperature data are used in many ways. We can give verbal descriptions, such as 2019 was the warmest year that we've had since 1880. July 2019 was the hottest month ever on record. Each decade is warmer than the last since 1980. So the 1990s were hotter than the 1980s. The 2000s were hotter than the 1990s, et cetera. And if we look at this year right now, what scientists are saying is that we're right on course for 2020 being the world's hottest year on record. We don't know for sure. We could have some changes in the next 6 months. But if we keep going the way we're going, this will be the hottest year ever. In March, we measured the world's average temperature, global average temperature, to be 2.1 degrees Fahrenheit above the average. Now, this is significant because what we say in general is that climate change has increased the world's average temperature by 1.8 degrees Fahrenheit. But in March, the world's average temperature was 0.3 degrees Fahrenheit higher than that 1.8. It might not seem like very much of an increase, but actually that little bit, remember that's an average around the world, is very significant. In February in Antarctica, we had a reading of 68 degrees Fahrenheit in Antarctica, another record, all-time record. So a lot of records always being broken. We're always hotter than we were in the past. We can show these temperature data on maps. Here's a good map showing the red up in the Arctic, which is increasing and it's heating up much faster than the rest of the globe for various reasons. And also we can do graphs and take these numbers and express them with several different computer programs. You can see that there's 5 of them listed there. And all of the graphs show that the global average temperature is increasing, going up and up and up. And once again, what we need to do is to flatten the curve, just like with the COVID, to get that temperature increase to be flatter. And we can use the data in a third way, or a fourth way, to show correlations. So here, for example, the white line is the carbon dioxide concentration in the atmosphere, and the blue jagged line is the temperature anomaly, the increase in temperature. And if you look at those are pretty much increasing right together. The carbon dioxide and the temperature increase are right in track with one another. And we can also use the data to draw conclusions. And we'll say here, globally, the average temperature rise from the 1880s has been 1.8 degree Fahrenheit or 1 degree centigrade. Although, as I just said, in March, it was quite a bit higher than that. We can say that sea level rise has risen on average 8 inches around the world, that the carbon dioxide concentration in the atmosphere has gone up 100 parts per million. Parts per million is tiny, but it's gone up from 300 parts per million or less before the Industrial Revolution to 410 parts per million now. We can use these data to consider the long-term past. Here is a graph going back 800,000 years showing that throughout this period, going on 1 million years, the carbon dioxide concentration in the atmosphere never exceeded 300 parts per million until recently, until we started to have very steep increases back in the 1980s. Both carbon dioxide concentration and global temperature started increasing and having these logarithmic, very steep increases. So this is not, it's not like commonplace or usual to have an increase in carbon dioxide concentration this much. We haven't had it. We know from 800,000 years. We know that from measurement of carbon dioxide in the little ice bubbles in ice cores that have been collected in Antarctica. We know that the carbon dioxide concentration was lower than 300 for that entire time period. It's now the highest in 800,000 years. And we can use these data to look at future possibilities. So what the models show, again, if we don't act by 2100, the global average temperature will go up something between 6 and 10 degrees Fahrenheit. Now, again, we've gone up, about 1.8 degrees Fahrenheit already. And by 80 years from now, one lifetime, we could be as high as 10 degrees Fahrenheit over the long time average. think about what our 1.8 degrees Fahrenheit increase has already done, and you'll realize that this is huge. If the global average temperature goes up 6 to 10 degrees Fahrenheit, basically, I think most people would agree that human civilization as we now know it would not be able to survive. Humans might survive, but not our civilization, not our world. It hasn't been this hot on the globe for 55 million years. So this is a big move to the distant past. Carbon dioxide in the air at that time would be 800 parts per million. It's now 400, would be a doubling of carbon dioxide. Sea level rise would be up 3 to 4 feet instead of 8 inches. And recently, researchers have said, because of the increase in melting of the Antarctic ice fields, the sea level rise by 2100 could go up globally 9 to 10 feet. So for the science, for both climate change and COVID, we can see we have a large body of scientific evidence and conclusions. The problems are real, they're serious, they're getting worse. For climate change, virtually there's no scientific debate. Climate change is now affecting all weather events. But the US public has been slow to accept and apply science. As with the warnings, science is sometimes discounted, thus we've lost time and the threats have been magnified. The lesson is that we have from this is that we need to study the problems, collect the data. This is imperative, but it's not enough. We need the science to be accepted and appropriate science-based responses and policies applied in a timely manner. So, third question, what effects have been seen? Both COVID and climate change are producing visible results, both what I'll call both primary and secondary around the globe. They're both changing things. With COVID, the changes are really obvious, illness and death. But there are a lot of secondary effects which we're struggling with now. The biggest thing being the economic collapse and the loss of jobs, and a sense of, I feel like just a sense of malaise. You know, you think about the shootings in Chicago this last weekend, hot days in a big city with people who don't have jobs anymore. It's just a situation that's rife for chaos, in my mind anyway. We know that the COVID virus also has its mental tolls, its tolls with school closings and the like. Climate change, the primary response of the increased carbon dioxide is that temperatures are increasing around the globe on average, and both in the air, on the land, and in the water. The ocean temperature is increasing. The temperature of lakes is increasing. In Iowa now we have all sorts of algae blooms that we didn't have anymore. That's because the water is warmer, and so it promotes algal growth in addition to the pollution, of course. And then we have lots of secondary effects that are diverse and widespread and sometimes less obviously connected to climate change, but are definitely present. And we'll talk about those a little bit. So let's talk first let's look at Iowa as an example of what climate change and COVID or climate change is doing. In Iowa, we know that we are a state, especially here in Johnson County, where COVID deaths are going up. We know our COVID cases are going up. But let's look at climate change now. Iowa, in the last 30 years, we have higher temperatures. Our average temperature has gone up on average 1 degree Fahrenheit, a half a degree centigrade. Remember, that's less than the global average, which is about 1 degree centigrade, 1.8 degrees Fahrenheit. It's a little bit less because remember when we talk about the global average temperature, we're talking about the whole world. And so we factor in the tremendous increase in temperature in the Arctic, which is warming more than twice as fast as the rest of the world. So they have it hotter up north. We have it a little bit cooler or less hot here in Iowa. And hotter air means wetter air. And indeed, research shows that our absolute humidity in Iowa has increased 2 to 4% per decade since the 1980s. Hotter means wetter because, as you probably know, if you have more heat and if the air is hotter, it can hold more moisture, right? I mean, in the hot summer days, you have these big cumulus clouds appearing. That hotter air, if the moisture is provided, the hotter air just holds it. It doesn't send it back to Earth as rapidly. And higher temperatures also means that we have more evaporation. So, for example, here in Iowa, one of the reasons that we have an increase in absolute humidity is because the Gulf of Mexico is evaporating more rapidly and sending more moisture up in that hotted air up to the Midwest. So our increase in absolute humidity is coming in part from the Gulf of Mexico. You know, all of these workings of the world are so interconnected. And a wetter atmosphere, greater absolute humidity means greater annual precipitation. And this number is really amazing to me. We used to have an average average annual precipitation in Iowa used to be 3 decades ago, 32 inches for the state, 32 inches per year average annual precipitation. It's risen the last 3 decades at 2 inches per decade, and our average annual precipitation is now 38 inches per year, which is a tremendous increase and a tremendously rapid increase in the average annual precipitation. This average increase also, whenever we have an average increase, we have extremes that are much greater than the average. And from the middle of 2018 to the middle of 2019, we had nationally the wettest wettest 12 months on record. So that 12-month period was wetter than any other 12-month period on record since the 1880s. And in Iowa, during that 12-month period, we had 51 inches of precipitation. So we've gone from average annual precipitation in 1980, 32 inches per year, to 2020, or maybe 1990, anyway, 2020, 38 inches of precipitation per year. And during this most recent period, we had a 12-month period of 51 inches of precipitation per year. Iowa's much wetter than it used to be. Hotter air also means that there's more energy in the atmosphere. When you have heat in the atmosphere, and heat is energy, and that means you have chaotic events in the atmosphere, which translate to more intense and extreme weather. You know, the really big rainstorms that we have in Iowa now are partially a result of that increased energy in the atmosphere, which comes from increased heat. And indeed, the research shows that in the Midwest in general, we've had an increase in extreme rainfall of 37% in the last, since the average has increased since 1950, about 37%. In the Pacific, or in the Atlantic northeastern part of the country, they've had almost twice that much increase in heavy downpours. So these are the gully washers that we have so frequently now. You know, they're not the nice gentle rains that we have. They're the times when in an hour you have 6 or 7 or 8 inches of water dumped down. Those are the heavy downpours that we're talking about. And the increase in precipitation, those heavy downpours, means that we have larger, heavier records. Time and time again, we have record rainfalls. The records are being broken. And the greater rainfall means that we have bigger floods, more soil erosion, more water pollution because that rain washes herbicides and pesticides and animal manure, et cetera, off of the fields into the drainage ways. We have more mold. We have more mosquitoes and diseases being transmitted by mosquitoes and by ticks. We have waterlogged soils. We have more asthma, all sorts of secondary effects because the hotter temperatures lead to a moister Midwest, which leads to all of these other problems. Globally, we can take that small rise in average temperature, again, about 1.8 degrees Fahrenheit, and we can see that we already have major effects around the world. The biggest thing being the warming in the Arctic. The Arctic, I think, has risen an average of 7 degrees Fahrenheit above their long-term average. You can see that with the red coloring up in the Arctic. It may be higher by now. Down in Antarctica, you still have some areas that are a little bit cooler than average. But in general, the Arctic is warming really fast. And that means that the sea ice is melting tremendously. It also means we have problems like starving polar bears and walruses that are in trouble. We have native villages that are falling into the oceans because they no longer have the ice shelves there to protect the buildings. But we also have more heat around the world, and we have all sorts of secondary effects because of that more heat. Again, we have more extreme weather because greater heat means more energy, so we have bigger hurricanes and bigger storms, bigger rainstorms, stronger winds, and the like because of climate change. We're very concerned about permafrost melting. And now we even have in the tundra something that was unknown in the past. We have fires. The tundra is actually burning because the permafrosted vegetation, the frozen soils are drying out and are burning. Sea level rise is increasing. The rate of sea level rise is increasing. And in general, the oceans are heating quite a bit. The more heat in the oceans means that we have lower oxygen concentrations, which means that some fish and some organisms living in the oceans are having problems. We find that fish populations are migrating hundreds of miles in search of cooler water. And one of the big concerns is coral reef die-off, big die-offs of the Great Barrier Reef around Australia, but elsewhere also. And other spin-offs, more erosion, more and bigger floods, sunny day floods along the eastern seacoast, cities flooded just by normal tides. The tides aren't extra big, there aren't any storms. It's just that the ocean level is enough higher that places like Miami Beach routinely now have parts of their cities flooded on a daily basis. More wildfire as the heat dries out the vegetation, bigger wildfires, disease spread such as Lyme because the vectors are spreading with increased heat, infrastructure collapse. All our roads and all of these things were built to function in a certain temperature range, and we're now beyond that temperature range. And seasonal mix-up. Spring, we now have on some years spring in December with some chorus frogs singing in December, violets blooming in December now for a couple years. So all sorts of spin-offs. And all of these effects are expensive. 2017 remains the record for the highest cost, disaster costs in the US of disasters that are related to climate. So in 2017, the US government paid $306 billion because of climate disasters. And that number of hundreds of billions of dollars, it doesn't happen every year now, but usually every year we have billions of dollars of climate disasters, but not hundreds of billions. but the forecasts state that by 2100, if we don't change course, every single year, we'll have hundreds of billions of dollars of climate costs. So in summary, the effects with both, we see many direct and spin-off effects. They touch all aspects of our lives, the social, dietary, health, educational, and financial. Huge costs from both COVID, tremendous costs, we know that, but also from climate change. Climate change is also affecting ecological and physical functions of the world, the severe weather, etc. Basically, what climate change is doing is reshaping the most basic ways that the Earth functions, and that the Earth has developed to take care of human and other life needs. Those are now being reshaped by climate change. We have what we call a new normal, permanent changes, can't erase them. With COVID, the effects of these changes have been rapid and direct. They're pretty obvious. We see the people out of work. We see the statistics. We hear them on a daily basis. With climate change, one of the problems I think with climate change is that the effects occur more slowly and they're more complex. And so, you know, the media hasn't been always that great about showing or writing about the effects of climate change, relating bigger hurricanes, for example, to climate change. This hurricane is larger because of climate change. The flooding is larger because the temperature is higher. We need more of that kind of education. And the lesson is that we need to apply COVID's initial urgency to climate change. And we need to connect the dots among climate change's diverse effects, collect the dots that state that one thing has caused another. And we need to explain the need to mitigate climate change and energize action. We need to say to people, hey guys, we really need to get going on this. So far we've said climate change and the COVID have been pretty similar in their science, in their predictions, in their end effects. Here we have a difference, the endpoints. Where are the COVID virus and climate change taking us? And this is extremely important. Both COVID and climate change produce unthinkable, unimaginable results. I think all you have to do is go back to your assumptions at Christmas. You know, I would bet that a lot of people, a lot of you listeners have at some Christmas gathering, you maybe talked about plans for the coming years. You know, the year that you assumed you were going to maybe visit your relatives or take certain trips or, you know, go out to eat more or less or something. And you had assumptions that were changed again overnight in unthinkable, unimaginable results. Both have changed lives and society, but otherwise, apart from these big facts, COVID and climate change diverge. COVID came in like a firestorm. It was fast and furious. But it has limited duration with a definite endpoint. What we still expect is that we're going to get a vaccine and good therapies for treating COVID so that COVID will become a memory. You know, we know that we're living through history now, but we assume that if we are talking to a grandchild, say, in 10 years, we're going to be saying, hey, you know, we lived through this COVID thing, and let me tell you what it was like. But with climate change, we're not going to be doing that. Climate change comes on like a glacier, strong, slow, and relentless. It's altering the planet's ground base, the very base of what makes this world works. And as I said in the last slide, it's now rewriting our planet's operating instructions. Climate change changes will extend long into the future. So why is this true? Well, basically it's because we cannot turn climate change or go back. You know, we are so used to thinking about problems as light switches, right? You know, we have economic collapse with the COVID virus. And if we take care of the economy and get the economy going again, then jobs will reappear and people will be happier and be able to consume and the economy will be back on track. That's kind of light switch, right? It flipped off and you're there working to flip it back on again, flip the good things back on. But with climate change, we're never going to be able to go back to where we were. The temperatures in the sky and on Earth, in the soil, in the waters of the world have risen, and they will eventually find a new equilibrium. But they will not, we won't be able to return those to what we were used to even 20, 30 years ago. It's just not going to be possible because in the atmosphere, 25% of the carbon dioxide that we are putting there every single day with every car trip we take remains in the atmosphere in 1,000 years. So 1,000 years from now, that little tiny bit of carbon dioxide that got there with your driving to the grocery store, a quarter of that is still going to be there affecting climate, rebouncing the heat back into the earth and causing additional heating. And in addition, the oceans hold 90% of fossil fuel generated heat. So when you think about the extra heat that has bounced back from those extra carbon dioxide molecules, 9 out of 10 units of that heat have gone into the ocean. And the ocean, the vast oceans that cover about 70% of the globe, have raised temperatures because of that. And because those things are massive, as I said, eventually, thousands of years, hundreds of thousands, millions of years, the Earth is going to reach a new equilibrium. That's not in question. What's in question is, will we be able to revisit life as we imagine it to be, as we expect it to be? Will we be able to maintain civilization with the amount of added heat that we are pumping into the atmosphere and that's affecting all of our events? Will we be able to maintain civilization now? Will we be able to stop that increased heat at a time, in time to prevent disaster? So for human purposes, the climate changes that we're now invoking are permanent and irreversible. We can't go backwards, but we can limit additional expressions. And this is what is crucially important, really crucially important right now, that tipping points were our points of no return. That's what we are trying to prevent now. We now have Arctic melt. The Arctic is melting. It's now underway. I don't think anybody thinks that we can go back to an icy Arctic in the summertime the way we used to have 10, 20 years ago even. But we can prevent permafrost melt, massive permafrost melt, which is really important because permafrost melting releases methane, which is a very potent greenhouse gas. So we've got to stop permafrost melt. We can keep Greenland from melting completely. If Greenland does melt completely, that will cause another 23-foot sea level rise by the time it's all melted. Now, this isn't going to happen probably in centuries, maybe not 1,000 years or so. But eventually, the melting of Greenland, if the whole thing melts, will raise sea level 23 feet. If the Antarctic melts completely, it will raise sea level 200 feet average around the world. 223 additional, imagine oceans 223 feet higher than they now are. Imagine how much less land surface we would have left in the world to inhabit, to grow food and the like. That's what we're facing if we don't stop, if we don't get going with stopping these tipping points. Other tipping points are shifts in the monsoons, collapse of tropical rainforests, slowdown of Atlantic Ocean currents, a lot of other tipping points, but these are the three main ones that people are concerned about now. So endpoints. What have we learned? COVID and climate change are both taking us into new worlds, but COVID will be limited while climate change will continue indefinitely for human purposes. And the lesson is that climate change is, people say, the largest existential crisis humanity has ever faced, the biggest thing that we as a species, as humanity, as a culture, as societies have ever faced. Permanent changes that are now possible through climate change could redefine civilization. And what we need to do is think about the amount of attention initially paid back to COVID virus. Think back to March and April when we were passing those huge stimulus bills, when the House and the Senate were working together to get those stimulus bills together to get out. And when our president was talking seriously about doing something big about COVID, that is the kind of attention that we need to pay to climate change for a long time period. So, climate change summary. Climate change is the defining crisis of our time. It's progressing faster than predicted. Urgent response is needed. We can't turn climate change off, but we can limit its intensity and avoid tipping points. We can keep the planet habitable for billions of future people and millions of species, but the response must be massive and fast. So what can we do? Solutions. Here, what we need to talk about is that these are similar. We largely know what to do. We know how to stop COVID. We just have to get that vaccine, and we need to get the therapies. We know what we have to do. We know how to do it. We're trying to do it right now with COVID. And we know the same things with climate change. We know how to stop this massive release of carbon dioxide into the air every day. And we know that addressing the problems will lead to better lives in many ways. We simply need to do it and to get going. With COVID, we need vaccine and medical treatments. We need prolonged social compliance. That seems to be a little harder here. Consistent policies, but the expectation is still that with time, the threat will largely disappear. Climate change is a much more massive and complex problem. It's had many approaches and types of solutions proposed. The general idea, though, is what we're working toward is a carbon neutral world. In other words, a world where our driving our cars, transporting ourselves, growing food and the like, is not releasing more carbon dioxide into the atmosphere. It's a carbon neutral world. And the most important thing here is the transition from fossil fuels to renewable energy. It's not the only thing we need to do. It's the biggest single thing. We got to get off of fossil fuels and go to solar and wind and other renewable energies. This transition is now happening. The question is only, is it fast enough? It's happening because we are learning to control our fossil fuel use in some ways, which I'll discuss. We're developing renewable energy rapidly and effectively. We're doing more energy conservation, new technologies that work towards this end. Government policies, not so good in this country, but other countries are doing them. International agreements, again, not so good here in the US, but they are still being made by other countries. And personal change. All of these things can contribute to a carbon neutral world. I'm going to go through these kind of fast here because I'm taking too long, as usual. We need to eliminate fossil fuels, period. The positive signs is that renewable sources of energy are now cost competitive. It's as cheap or cheaper to build a renewable energy plant as it is to build a new coal-fired power plant. It just doesn't make sense to use coal anymore. There's a large divestment movement which keeps increasing tremendously. It's now the largest divestment in history. It's over $12 trillion have been divested, the largest in history. I read just in the last couple of weeks that the Vatican is joining the divestment movement and getting out of fossil fuel investments. That's fantastic. In the last 5 years, oil has been the slowest growing sector on the stock market. If you want to make money, you don't invest in oil anymore. But the problem is that oil companies by our government are still being subsidized, even though they make tons of money they still get subsidies, and renewable sources of energy do not get those subsidies, at least not in the same manner or size. And so what we need to do is to transfer those oil subsidies to renewables, and we need to put on some sort of a price on carbon, get some sort of a carbon tax. Renewable energy falling cost, rapid growth. In Iowa in 2018, over 50%, 30% renewable in Iowa in 2018. By 2020, we are supposed to have over 50% of the energy generated here, generated by solar power and wind power. Mid-American Energy says that by 2021, it'll be working on 100% renewable energy generation. It'll be, if it does that, it'll be the first company to do that in the world. Jobs in Iowa, 9,000 wind power jobs, 88,000 in the United States. In Iowa, 800, so we have 800 solar energy jobs. Fastest growing professions in the US are wind and solar technicians. Google, Apple, and Facebook buy 100% renewable energy. They've dedicated to that consumption. And these companies, these high-tech companies, use about 10% of the US energy. So right there, we have companies that consume 10% of our energy, which say they are going to buy only 100% renewable energy. This kind of commitment, just a minute. Somebody keeps trying to call me. Hey, Bob, can you turn that off, please? Can you get rid of this, please? It's been ringing repeatedly. Yeah, thank you. Okay, sorry. My husband's cell phone. Okay, so we're transferring to, a lot of people are transferring to using only renewable energy, and it's what we need to do. The rest of the world is moving forward. China, the largest solar production and installations in the world. You can see two things from space in China, the Great Wall of China, and their big solar installations are very obvious from satellite. India is also going big time to solar. India says that it's going to be, I think, 60% renewable energy by 2026. Africa is not even getting, it's jumping to what we call diversified energy, getting energy installations on, for example, small schools, in little villages. They install their solar panels and their batteries, and just have their energy. They're jumping from like no energy to renewable energy without fossil fuel energy in between. Great Britain and Australia in the last year have both had periods where the entire country has been running on renewable energy, on a majority of renewable energy. In other words, over 50% of their energy in the last year at certain times came from renewable sources. That's tremendous. European Union is committed to 100% renewable carbon neutrality by 2040. Carbon neutral by 2050. We have Canada, New Zealand, Britain, France, Sweden, Norway, many more countries, and a lot of cities and states have committed to being carbon neutral by 2050. Energy efficiency, we have new buildings being built that are both carbon neutral and some that are carbon negative. This building in Beijing, it gets all of the energy it needs for its consumption by the solar panels that you see on the surface there. And some buildings are built, I think that the one at the Indian Creek Nature Center up in Cedar Rapids is now carbon negative. It actually takes in more carbon dioxide than it releases. Old buildings, we have regulations for older buildings being renovated so they're more energy efficient in New York City. Older buildings earlier than a certain date now have to be renovated so that they greatly reduce their carbon dioxide, their fossil fuel use by 40%, or they face stiff fines. And New York State is going to be carbon neutral by 2040. New technologies, the switch to electric vehicles is going on big time. Tesla is the biggest seller. You see more and more Teslas on the road now. VW is supposed to go all electric by 2026. Ford is going to have 40 electric models by 2022. Billions of dollars are being invested in building charging stations across the country now. China, Britain, and Norway are talking about banning fossil fuel cars, both banning their manufacturing and banning their use in those countries, which is amazing. They're just saying, we don't want these anymore. China has hundreds of thousands of electric buses. Los Angeles, Paris, and London are only going to buy new electric buses, only electric buses by 2025. Amazon earlier this year ordered 100,000 electric delivery vans that you'll start to be seeing on the road in 2021. And in January 2020, this amazes me, Delta Airlines pledged itself to become carbon neutrality. You might know that the airlines are some of the toughest things in terms of getting neutrality, carbon neutrality, but they pledged to do that. The caveat here, and something I don't really know, I haven't seen much about it in the writing, is has COVID-19 changed any of these initiatives? That I can't answer. Government policies and laws, we know that we pulled out of the, we're pulling out of the Paris climate agreements, which is a huge thing for our country to do. It's really reshaping history in a negative way. But once President Trump said that he wanted to do that, a number of cities and states said that we are still in, we want to still have the same restrictions or work toward carbon neutrality at the same rate that the federal government was supposed to be doing. Our Iowa City is supposed to be carbon neutral, I think, by 2040. A lot of cities have done this. They've signed a pact to do that anyway. Citizens Climate Lobby is a very active group that's working toward putting a price on carbon. It's supposed to be working successfully toward that goal. We'll see. I think a lot depends on the next elections. And personal decisions matter. Everything that you do affects the carbon dioxide in the air in some way, either increasing it or decreasing it. Hanging up your clothes, you use less electricity. And if that comes from fossil fuels, you decrease the carbon dioxide going into the atmosphere. Transportation is important. Energy efficiency, all of these things. If you're going to put in solar panels, if you're thinking about now is the time to do it, you can get on the web, measure your carbon footprint, and measure and work toward climate neutrality now. So, just a few personal things I'd like to say. I think that we all have to and must respond. We can all make a difference. Acting is the best antidote to becoming overwhelmed and depressed. We have to keep learning. We have to stay connected and involved. We have to talk with others about our frustrations and our successes both. And we really have to advocate, and I think especially, again, work toward the coming elections. If we don't address, I like to say to people, if we don't address climate change, nothing else matters. So really, in my mind, climate change is if I were a single issue voter, I would pick climate change to be a single issue voter about. So we need to work to stay positive. We need to think of climate change as an opportunity that will reduce disease, produce a less polluted environment, because we're not putting all that junk from burning fossil fuels into the air, creating new jobs, creating fewer wars and tensions, again, because we're not worried about getting fossil fuels, and cultivate hope as a way of thinking. We need to do more faster and help speed up that positive transition to renewable energy. If we want to do anything, just think about ways that you can do that one thing for climate change. So here, finally, we get to the main point of this talk, which is how might the COVID virus help us deal with climate change? So these might seem like really simple things to you, but I'll tell you, it took me a while to figure all this out. I think that COVID has given us motivation, methods, and opportunities to deal with climate change. And in that way, the COVID virus, I think, is not all bad. It's shifted the world. It's changed the world so much that we need to start thinking. And I think we realize that we need to start thinking about these other problems, including climate change, more. As humans, we are so, we tend so much to think that the unimaginable cannot happen. You know, we go out in the car and we don't think that we're going to be the person to get in a big accident and be killed. We don't think that climate change is really going to do anything to us, that our house is going to be the one to flood. I mean, item after item, we are people that hope all the time that the unimaginable will not happen to us. But what COVID did was to say, yeah, the unimaginable can happen. And you're at risk. You are at risk for getting the COVID virus and for possibly dying from it. It can happen. Look at the statistics. Look at how many people it's happening to already. So I think that was good for us to be shown that the unimaginable can happen and that it has happened, and also that we as a country, as cities and states, as a world, can deal with unimaginable crisis. Because we have, you know, we're not doing the greatest now in Iowa, I know, in the country. I know that. But think back again to March to April, to early May. We managed to have bipartisan agreement and get these massive stimulus packages passed. We did it. The healthcare workers found the strength to keep going to the hospitals. We managed to start sewing masks that were needed and to distribute them. We did all these things. We had cities and states proclaiming policies and encouraging people or forcing people to stay home, to shelter in place. So we know that dealing with these huge crises is not impossible. And I think we need to learn, it needs to register. Bad things can happen and we can deal with it. We don't always know that. And that we can get demonstrable benefits from both of those things, from dealing with the crisis. With COVID, we see decreased fossil fuel use and lifestyle shifts that have been very positive. With fossil fuel use, the use of fossil fuels, because of people staying at home more, by April, we had a 17% decrease in greenhouse gas emissions, 17% less, just because we weren't traveling so much, going to work, etc. And that decrease of emissions decreased the particulates in the air by 35%. Global average. And I'm sure you've seen these pictures of large cities that used to be, you know, you couldn't see through the smog. And now, because of the virus and decreased driving and the like, the air is crystalline clear. And we can expect that health problems, asthma attacks, allergies, etc., decreased as a result of that. We've also heard a lot about lifestyle shifts and about how people are finding parts of themselves that they didn't know maybe existed before. People are starting to bake bread or have been, you know, staying at home. They're finding the benefits in a slower lifestyle. On the radio, I listen to stories of the kindness that people are showing to other people, lifestyle shifts that only have happened because of the pain and the restrictions we felt because of the COVID pandemic. So those are demonstrable benefits. The COVID virus has also given us methods, and this might seem kind of weird to you, but I think that in March, when President Trump started to talk about himself as a wartime president, that really struck me in a positive way. You can say you hated it, but the thing that people have been saying for years about climate change is that we need a Manhattan Project, the project where people hold up in Los Alamos, New Mexico, to build the atomic bomb. I know the atomic bomb isn't great, but what I'm saying is that that project put minds together and gave them unlimited resources to come up with a certain project and solve a problem using a certain project by developing this horrible bomb. So I'm not saying that the wartime mobilization and the Manhattan Project were wonderful, but that was a metaphor that Trump used to energize our actions about the COVID pandemic. He said, we can come together, we can solve this, we can develop a Manhattan Project that will address the COVID pandemic, and we can solve the problem. And I think that that is kind of a method. What we need to do now is to say, we can have a Manhattan Project for renewable energy and for other climate change positive actions. And the thing that other people are talking about a lot is a green economic recovery. Britain and Germany have both said we need to tie our economic stimulus plans, our COVID recovery, we need to tie those to climate change. So you're taking these two massive projects and you're saying COVID virus, COVID pandemic means we have to shunt masses of money that we couldn't think about before. We're going to have to put those economic stimulus funds into the country in order to solve the problem. And then they're saying, if we do that, let's use these funds to also address climate change. And the International Energy Agency, the IEA, recently came out with a plan that it's starting with the IMF, the International Monetary Fund, to stimulate economic growth in a sustainable way. So these are projects that will go to home renovations, to renewable energy and the like, things that will limit climate change and get the economy going once again. The article that I read had this quote: "The world," this is from the International Energy Agency, "the world has a once-in-a-lifetime opportunity to pour investment into clean energy and to create millions of new jobs. What we need are sustainable recovery programs." So I think those are, especially that green economic development, is what we need here in this country. And then I want to say that what COVID has done has to give us opportunities. You know, it is such a horrible time to be alive. It's, as I said at the beginning, I think that we're all wondering, what's our future? Where are we going? And, you know, my husband and I are in our 70s now. We're saying, when are we going to be able to visit our grandkids? You know, we don't know how much longer we have on this earth. Are we going to be able to do things once again and enjoy life the way we want to? And what about those people, you know, our kids who are worrying more about their families and their job stability and the like, and the other people who are suffering? What can we do to help alleviate those problems? We also want to get involved with that. But COVID has changed the world in so many ways. I was going to talk about the airplane example. Maybe 2 weeks before COVID struck, I was talking to a friend. We were talking about climate change, and this friend had just come back from Mexico, and we were talking about how flying airplanes really releases a lot of carbon dioxide. And this friend said, you know, people are never going to give up their airplanes flights. They're never going to give up their vacations to foreign countries to you know, go birding. She goes birding, to do the like. We're just, the airplanes are going to have to become less carbon intensive, but we're not going to have less economic fewer flights. And then like a month later, nobody is flying. I mean, that was impossible that anybody would have thought that that would happen. And yet it did happen. And right now, we're looking at the possibility, what I've heard is that at least one of the major airlines is going to go bankrupt, probably disappear. And most people that I know, you couldn't pay them to take an airplane. It doesn't matter where they're going. They're not going to get on an airplane. So things have changed tremendously, and there's a vacuum right now. And the human urge will be to fill that vacuum by returning to the past. But we can't return the past to the past. And do we really want to return to the past? Do we want to return to a place where the burning of fossil fuels is causing hundreds of thousands of premature deaths around the globe every single year, where the air is polluted, where the skies are not crystalline blue, where where all of these things where we have the threat of war with the Middle East because we have to get their oil, or we have to put pipelines across our Iowa farm ground to get this fracking oil out to processing centers. Do we want to really return to that? Or can we say, we're in a vacuum now. We are going to instead build a better future. It seems so obvious to me that this is something really good. And I think about the muddle. I feel like I'm kind of in a muddle now, like I don't really know where we're going. But when you think about it, meaningful change happens in muddles, in difficult times, in times when you are pushed to your limits. That's when we change in a major way. So, is COVID virus a dust rehearsal for climate change? I'd say yes. I'd say that COVID is giving us a chance, another aspect here. It's giving us a chance to practice how to address a major environmental crisis. We can now see the many responses that we've taken to COVID and to climate change, and we can look at COVID and we can say, some things work, some things don't. Some countries are doing it, some countries aren't. Some attitudes work, some attitudes and approaches don't work. We are tinkering with these things now, and we're kind of gearing up for changing in a better way environmentally, I think. And I agree, and I understand that the US, I think now is moving backward. I don't know if you've seen this graph of number of new cases in the United States. This is a number of new cases every day in the United States, and we are going backwards now. We're increasing, as you all know, in contrast to April and May, where we were actually taking that curve down a little bit. We're now going up. I heard on the news last night that in the first 6 days of July, we had 300,000 new cases of COVID virus in the US. That's horrendous. It's horrible. We're going backwards. But that allows us to see what doesn't work. We're kind of getting trained, right? We're learning things. We're seeing that reopening too fast doesn't work. Reopening without masks, distancing, testing, and tracking doesn't work. And we can see something that I think is really interesting. So climate change has always been ignored, politicized, treated as something that is, you can take it if you want, but it doesn't really matter because it's not going to happen to you. It's going to happen to somebody else in the future. We've always had excuses for ignoring climate change. And now we're doing the same thing with COVID, right? We have all these young people going out and partying because they're not going to be affected. So that's something interesting to me. But more generally, we can also see that both for climate change and for COVID, we have had certain excuses. We've discounted the reality of the crisis. We haven't understood the problem's severity. We've been denying and ignoring science. We've had weak leadership, weak messaging, weak and inconsistent policies. We've been clinging to old patterns, behaviors when they don't work. We've been yearning to return to the past. Isn't that what this opening up now is, right? We're trying to go back to the past rather than creating a better future. And we yearn to return to the past, but we can't anymore. It's not going to work. We've changed. The country has changed. The world has changed. And we don't have enough attention to the common good, to the needs of others, and to those of yet unborn. In a sense, I think that many people in this country are living a delusion. They think if we ignore the problem, it will go away. And they're thinking about that with the COVID virus, and they thought that for decades with climate change. But we can also see what will work and what we need for both COVID and climate change. We need good recognition of the problem, appropriate responses, adherence to science. We need to see that the background noise is always going to be shifting and changing. And the good lesson here is that the COVID virus, you've probably read that the COVID virus is now mutating, and this mutation has traveled from Europe to the United States. The new virus is more infectious, more potent, but it'll spread to people more easily, but its results necessarily won't be necessarily be worse, but it does complicate the vaccines. So, here's one little piece of information. We need to incorporate that into our database and go forward from there. We need consistent, strong leadership that sets directions, policies, messaging. We need to say this is where we live and not always want to go back to the past because it won't work. We need a dedication to the human good, human hard work, and to sacrifice and immediate action. We need to act now on stuff, but we need to stick with it. That's the opposite of instant gratification, which is what we all often want. So here we finally, I apologize for talking this long, but we finally get to your thoughts and questions for me or for the group. Or